Showing us lost the comms there.
Show me specifically. That's the folder, and that's where the comms went off.
And it actually says comms.
Yes.
Okay.
And okay.
So that is what's done it. So we can put that back now.
So if you were missing a whole bunch of comms, you'd suspect your one of your switches went bad.
Exactly.
Went bad.
We'd go and look at that first. That's come back and it's all happy again. And the triangle's gone. So that was an indication of fault. So what else have we got on here? We've done the selection. We are going to look at, we know about the level detectors briefly, don't we? We've looked at them. So these are all the press interlocks and various level detectors that are used. And I think
Have we looked at the all the button inputs, the stop, start, increase, decrease?
No, but we can if you wish.
Yeah, I don't think it would hurt.
They're in the drive sequence program. At the top. And we will find them. There's, if it's master, there's the slower, the inch, the ready. No, the place that they're used is in the ramp. The ramp generator here, speed ramps, is what allows us to ramp the press up in speed. And there is a little bit at the bottom which allows us to go sort of softly and to the correct speed. So this here has been the inch mode. There's the inch speed. So when we go into inch and the driver started, we will increment these by the ramp rate further up, this number, till it matches. And it just increments it every scan of the program, which is set in a time, so it's linear of, I think it's 20 milliseconds, and it will just increment this number until that speed reference is equal to the inch speed. That's what that does, and that's in principle is what it does when we go into the run mode. And as long as the press is less than 60k, it will just keep incrementing it while the man has his finger on the faster button. And there's also one that for the slower button, which decrements it and it goes down.
Right.
And there is another one for the E-stop, which if you press the E-stop, it takes a much bigger number and it decrements it on every scan, so the thing comes down quickly.
So can we look at the e-stop input on the logic?
Well, yeah, we can look
Because
at,
that's 2 wires into the master, right?
no, it doesn't quite work. You know the stop loop we were just looking at?
Yep.
There it is. Do you remember I said if you lose the stop loop and you're running that, you set that e-stop flag?
Right.
Once you get an e-stop, what it will do, it will ramp. It will, once the sequence is brought in the reverse for the fin core, because we've got a mixed system.
You regen. Okay.
It will subtract 75 every scan in 20 milliseconds. So that will just ramp down until that hits that is detected elsewhere, 0, and stop.
So if Tony was to go out and hit an e-stop right now on this press, would we see a change of state in that contact?
I doubt it is still.
Right. We're not in a running mode.
No. and you have to be at some speed.
Okay, if we were at some speed, we would see that turn green?
Yeah,
Okay.
and it would decrement to the hits 0, and then it resets, because that's at the bottom of the drive sequence. That is where it resets that. If I remember, that's where I put it. No, that was a guess. Where's this? Where's the E-stop? Where did I put the E-stop? Ready? Somewhere. I don't remember it. So there's the E-stop latched. Do E-stop. Now, where does it stop it? So if you've lost the stop and we're in run, we set the bit. So we can find this by looking where we unset it. And there's where it unlatches it. And it unlatches it when we hit still.
What's still?
The presser stopped.
Oh, the press stop. Okay.
That's standstill.
So that is feedback from.
The actual speed of the press.
But where's it coming from? The drives, or is it coming from the old FinCore?
No, it comes from the
Attack.
It comes from the master drive.
It comes from the drive.
Yeah.
Okay.
So it looks at the speed that the drive's actually doing. When it gets below that number, when we looked at the standstill, it declares itself as at still, and it resets the stop.
And all those other things you just showed us, the end speed and all that, it's that's reacting to the drive as well, not to the tacho inputs from the old FinCore system.
No,
Okay, good.
no, it's all based off the new Drive Masters. But yeah, so that's the ramp. So that's what that does, and that is again, I would say it's a program that has had lots of outings in other sites, and that's sometimes why we get values in them that are not appropriate for this site or any other site, because it was where it was last.
Sure. Did we already yesterday, and I probably am just forgetting things, did we already cover the PD relays or PD outputs? Did we go over that yesterday? I thought we did.
A little bit.
Yeah, we know where all the relays are, and we looked at the level detectors briefly as well.
But we haven't actually looked at the PDs in the circuitry.
In
yet.
the software.
Yeah.
I thought we just did.
Did we? Okay, good enough.
I thought we looked at the level detector. They're called level detectors.
Okay.
Now the other thing, that every drive has an output. So we'll just have a quick look at this. And what this does is it controls all the outputs to the drive. So the drive's active. It sets the current, which is based on the current limits set in the thing, and it sends from the current demand the torque reference to each of the individual drives, depending on selection. So we will only be doing the ones that we have selected, which is further up. And that's the ones we have selected. So it will be passing this information to each of the drives
Via Ethernet.
via Ethernet. And that's all the drive. That's all the master sends the drive. It sends it a torque reference, and it tells it that it's what currents that we've set is to be the correct currents. These currents, the regen currents, they change depending on the mode. So at this point in time, we have no current. We're not allowed to go backwards. But when we're stopping, we need some regen current to break the press. So that number will depend on where we are in the speed. We'll set the appropriate current limit for braking.
Based on how fast you are going.
Well, yeah. so it will in this instance here, there's the e-stop. So for an e-stop, it will set the reverse current to the correct levels for
Right.
actually stopping. But that's what that does. And it will also clamp the speeds, because the speeds, you don't want a speed which is not in the range of where you want to be.
So if there is no actual physical input from the shaft, and you're strictly relying on the master telling you what type of current to be delivering to the individual drives, how does it know when the shaft is stopped? How does it know when it's physically...
There's no back EMF from the motor.
Ah, okay. That makes sense.
Yeah. You couldn't have, you could, 15 years ago, you couldn't really have done what we've done here.
Okay, gotcha.
With a drive.
But the drives are that sensitive if there's back
They're
EMF.
that good.
Gotcha.
But you can't do everything like this. Some things you still have to have encoders, but something like a printing press is not one of them applications where you have to have very high speed accuracy.
Okay.
Paper mills, you have to have very high speed accuracy, otherwise you just tear the sheet because it's all soggy and wet. Whereas on the printing press, you know, everything runs together on the line shaft, so nothing can change against anything else instantaneously. The only thing you have to be worried about is backlash in the system, which you fix elsewhere with the gain control. But it's a good way of doing it, and it's considerably more safer than having encoders with little belts on presses that fall off and the press goes woo, because you've got a lot of power behind this.
Okay, so we're running our press up. We can't get our impressions to come out. We know our impressions are a function of a PD relay.
Yes.
So I want to see, and I look down and I see there is actually a physical PD relay in the master right now.
Yeah.
So it's not turning on. I can see that it's not turning on. So I want to know why PDB is not coming on.
So PDB, we'll look at PDB in this scenario, and it is in the level detector program. And there's PDB. So when the press is above 1500 copies, it should turn PDB on.
And that output activates that relay.
Yes.
Okay, perfect.
And as you can see, PDC comes on at 1000. Now you can change these to suit yourselves.
No thanks.
No,
I'm trying to quit.
Yeah.
If it ain't broke, don't fix it.
Yeah.
All right, what else do you think is important for us to see, Ian?
That's the basics. A lot of stuff there's a lot of stuff in here which is to do with displays, and that's all in the HMI. So all the things that put numbers on the screens, it's all in here, but it's not critical.
It's not stuff we'll mess with anyhow, really, to tell you the truth.
It shows whether things are active and such like. So that drives the thing that tells us which colour it is on the screen, and it's telling us with it puts these numbers in, and from them numbers, that puts the correct coloured motors on the little screen.
Yeah, I don't think we'll be needing to mess with that.
Yeah, I think what I've showed you is the bits that are things that will stop it running.
The important stuff. Give me a tour of this set of what are these files that we're
Right, these files here. So these are the
Oops, wait a minute, I'm too far. Sorry, go ahead.
these are the programs that are called from the main task. So the program constantly circulates through the main task and does each one of these little programs sequentially,
Okay.
and does that forever.
Every 20 milliseconds or something?
No, it just does it all the time.
All the
So when it
time.
gets to the bottom, it starts again. Now, what we have these ones with little clocks on, they're timed functions. So this is a little program for the ramp, and this is a little program for the speed controls. So if we look at the ramp, where the little clock is, we look at properties here, and this is the configuration. So every 20 milliseconds, it will stop doing whatever it's doing in here and go away and do this. And then return. That's what that does. So that's a periodic program.
Okay.
And this one here is the speed control, which sends the outputs to the drive. And that's configured to be every 20 milliseconds also to send out a program at all these parameters that we looked at down here, the speed, the torque command and everything for the drive. And that's all it does.
Okay. So, for our purposes, the press won't run. We have to figure out why the press won't run. Which one of these are we more likely to be looking in?
Well, that's what I said to you. Them first three rungs will tell you if the press won't run, why we haven't got to stop, and why
The
we're
first three rungs, meaning the first three.
not the first three rungs. I think it was 6, 7, and 8 in drive sequence.
In drive sequence. That's where we want to be.
Yeah,
Okay. Drive sequence.
yeah, which is the one we've been spending.
We've been working on.
Yeah.
Okay.
But yes, as I say, there's other things in here, but I don't think.
Not stuff that we need.
Yeah, and I mean, there's some stuff that's temporary it's programmed, and I don't take it out. As I say, we use this software.
And you were going to show us how to load the software onto the One Master. Is that something we should still do?
The software. I think Mike's familiar with putting the program.
Yeah, but didn't you want to, you had a module that's not being used that you were going to upload, get rid of it, and then re-download?
Press A.
Right.
We can do it.
And the other thing is, Mike's not here 24 hours a day,
Right.
7 days a week, and Mike goes on vacation and whatnot like that. And we've got to be able to.
Yeah.
I need more than just Mike.
No, I can show you this. If you can get me press A for 5 minutes.
Okay.